The first phase of any AI project under the CPMAI framework begins not with code, data, or models, but with business understanding. It's the moment where teams pause to ask the most important questions. What problem are we really solving? Why does it matter? And how will we know if we've succeeded? Defining the business problem is the starting point. That means sitting down with stakeholders, asking the right questions, and digging beneath surface-level pain points to get to the core challenge. Often, what sounds like a generic frustration, such as, customer churn is too high, can be reframed as an opportunity for AI to add value. In one telecom company, it turned out that a significant portion of churned customers had unresolved support tickets. By using an AI model to detect negative sentiment in those tickets and flag at-risk customers, they reduced churn by 18%. That shift, from symptom to insight, is what makes a strong problem definition so critical. Next comes the question of success. How will we measure it? Defining clear key performance indicators, or KPIs, brings structure and accountability. These metrics need to span both business outcomes and technical performance. In the churn reduction example, business success might mean reducing churn from 30% to 25% in 6 months. On the technical side, model precision might need to exceed 90% to be considered viable. In another case, a healthcare company saved $2 million annually by reducing manual claim processing time by 40%, a result only possible because success criteria were clear from the outset. With the problem and the success metrics defined, it's time to identify the AI pattern that fits. AI isn't a one-size-fits-all technology. The Cognilytica framework identifies 7 major patterns, such as predictive analytics, anomaly detection, or conversational systems. Mapping a business challenge to one of these patterns helps guide the design of the solution. If the problem involves anticipating behavior, like which customers might cancel, a predictive analytics pattern is likely appropriate. If the goal is to detect fraud, anomaly detection is a better fit. One bank, for example, used this pattern to cut false positives in fraud detection by 60%. Every AI project also faces constraints. That might be gaps in the data, legal limitations, budget restrictions, or technical dependencies. Taking time to assess risks, using tools like SWOT analysis, helps teams avoid surprises down the road. A common risk is incomplete or low-quality data. Another might be compliance with privacy regulations like GDPR. In one HR analytics project, concerns about employee privacy delayed progress. The team ultimately resolved it by anonymizing the data and adjusting the scope. By recognizing these constraints early, they avoided costly rework later. Trust, too, must be part of the foundation. That's why trustworthy AI requirements are built into this phase. This includes reviewing fairness, making sure the model doesn't discriminate against any group, transparency, ensuring the model's decisions can be explained, and accountability, defining who is responsible for each outcome. Teams might use explainability tools like SHAP or LIME to open the black box of AI, or perform bias audits to ensure fair outcomes. In one insurance company, underwriters were initially skeptical of AI-driven policy recommendations. Once explainability dashboards were introduced, trust improved dramatically, and adoption followed. Throughout this phase, documentation is more than just a paper trail. It becomes a blueprint for the AI solution. It captures business intent, aligns teams, clarifies expectations, and sets the tone for responsible development. When teams take the time to deeply understand the business challenge, define success with precision, and plan for risks and ethical considerations, they don't just set the stage for a technically sound solution, they create the conditions for meaningful, measurable impact.